What enables hydraulic seals to function? Water has been used as a power source by human beings for thousands of years. Water wheels have been used to produce food and materials, and water itself is used extensively in heavy industries such as mining. In the modern world, hydraulic power uses pressurized fluids to create movement of components within a machine, such that useful work happens. Hydraulic seals are the parts within the hydraulic system which keep the fluid, gas or liquid where it should be, that is, inside the hydraulic system. So, assuming that the end user has procured the appropriate seal for their application, what are the physical principles which make hydraulic power function? Liquid pressure. In 1586, a Flemish engineer called Simon Stevin established two important principles. Firstly, he proved that for any body of water at any given depth the pressure will act equally in all directions. The second principle established was that the pressure in any body of water will increase with depth. In addition, it was well known by then that the pressure that any fluid exerts for a given depth depends on its density. In the mid-17th century, the great French mathematician and philosopher Blaise Pascal formulated the law that bears his name. In 164,748, he designed a machine that used the incompressibility of liquids to multiply the pressure that they exert when they are moved. If there are two pistons in a hydraulic system where one is 10 times the area of the other, then the larger piston can support 10 units but will move only 1/110th of the distance through which the smaller piston was moved. The machine itself had no functioning hydraulic seals, and so was only suitable to demonstrate the principle that, if there is an increase of pressure on a contained fluid, then there must be an increase in pressure at every other point in the container. In other words, when the force of pressure is transmitted by the movement of fluids between pistons, work will occur due to the pressure it exerts. Today most vehicles use hydraulic systems in their braking and or landing systems. Pneumatic systems apply the same principle, but the fluid in question is a gas as opposed to a liquid. Bernoulli's principle, Pascal's law, and the Bernoulli principle have without doubt formed the absolute foundation of the engineering and scientific discipline known as hydraulics. The Bernoulli principle, which applies to gases and liquids and was discovered by Daniel Bernoulli, a Swiss physicist and mathematician, in 1738, explains the behavior of fluids that are moving in a confined space. The principle states, perhaps counterintuitively, that when the rate of a flowing liquid in the container increases, the pressure in the fluid decreases. The opposite occurs when the rate of the fluid decreases, and any mechanism which uses a jet or nozzle applies this principle. Any machine that uses an aerofoil, such as an aircraft wing or propeller, uses the difference in speed across a flat and curved surface to add extra lift for the aircraft as it moves. In the 18th century, the Bernoulli principle was used in the first machines that used steam-driven pumping systems and pressurized water, thus allowing pressure and therefore power to be transmitted over increasingly larger distances. Only the discovery of electricity, knowledge of which goes back several thousand years and is difficult to credit to a single individual or research team, superseded the utility of these machines. In the 21st century, hydraulic power is all around us. Everything from heavy machinery to a Bunsen burner uses the principles outlined above. Hydraulic seals function by sealing the fluid inside the container, thus maintaining pressure and therefore the efficiency of the machine in its entirety.